Welcome to the final lesson in Chapter 6, More About Triangles. This lesson is about the coordinate plane distance. How do we find the distance between any 2 points? We're going to start by using the coordinate plane to plot these 2 points, and then we're going to find the distance between them. So the issue with finding distance on the coordinate plane between 2 points that are not on the vertical or the horizontal is that they're not always an easy measure to just count. We could count the slope here, but the slope is just telling me the relationship between the rise and the run. It's not giving me the actual measure of this line in units. So it's not giving me the actual distance between this line. So instead, we're going to use the Pythagorean theorem from the last lesson after we make a right triangle. And it doesn't really matter how you connect these to make a right triangle, but we are just counting these, technically using the slope because we are counting rise over run, but in a different way where we need to find the value of C of that hypotenuse, and that would give us the distance between F and G. So using the Pythagorean theorem, we get down to the point where we have to take the square root of both sides, and I'm just gonna leave it as the square root of 29, which remember is an exact answer. If you wanted the approximate with the decimal, it would be about 5.39 units. And so that is the actual measure of the distance of FG. And again, we would not be able to, especially when you see these answers here, you can see that you'd not be able to just count and figure out 5.39 or the square root of 29. We had to use the Pythagorean theorem, creating that right triangle there to find that actual slanted distance. It just so happens we can always use the idea of creating a right triangle when we have a sloped line. And we can always use that idea of creating a right triangle to use the Pythagorean theorem to find the distance of that line, which would be C, would always be the hypotenuse. So if we look at any 2 points, and so we're gonna make it x1, y1 is this point S, and N is down here at x2, y2. Remember the little ones and twos are just telling us that this is the first point and this is the second point. So when we go to find the height here, we would have to take y2, because when we're dealing with height, that's a change in the y-axis. So we would have to take y2 and subtract y1. And then for the distance on the x-axis here, that length of that other leg, we'd have to subtract our x's. So x2 minus x1. So over here, the length of RS is going to be y2 minus y1. And the length of RN, this other leg here, will be x2 minus x1. So if we use the Pythagorean theorem to help us find the actual length of C, let's make the RN be leg A and RS be leg B. Then it would look like taking x2 minus x1 and squaring that, plus y2 minus y1 and squaring that, and that would equal C squared. And then the weird part is that then we'd have to square root all of this to actually find the value of C. And of course, I'm not going to try to actually simplify this whole side. It's just going to be this representation, and believe it or not, that actually leads us straight into the distance formula. Let's go ahead and get the distance formula, which remember is just an easy one-stop Pythagorean theorem. So if you are good at memorizing formulas, this is the formula for distance on a number line. It is an easy one-stop Pythagorean theorem because if you think about it, it takes the a squared plus the b squared and it square roots it, because that's what we do every single time when we're solving for D or C. In this case, we're using D to represent distance, but distance is really going to be that C, that hypotenuse value. In order to get that by itself, we always end up square rooting the sum of the squares. And those side lengths are coming from these subtractions that we did on the coordinate plane. Just to take a second look at what we did here. Remember, the legs came from subtracting the distances. So this distance here is coming from taking the y values and subtracting them. This distance is from taking the x values and subtracting them. And they're simply used in the Pythagorean theorem, and this is what happens every single time. So if you're better at kind of understanding where the numbers are coming from and why the formula is what it is, this is why the formula is what it is. But if you are a person who is good at simply memorizing formulas and just understanding how to plug in formulas and use formulas, this is all you really need to know. So let's go ahead and start using the distance formula to find the distance between the following points. So we get started first by remembering what the distance formula is, and that we realize that we need x1s and y1s and x2s and y2s, and those come from the points. So this is the first point, 6, 2, x1, y1, 4, negative 4 is x2, y2, and then we start by just plugging it into the distance formula. So our x's would be the 4 minus 6. If we're going to do 4 minus 6, that's going to then be squared. Negative 4 minus 2 will then be squared also, and then those sums will be added together. So that's the difference. So 4 minus 6 is negative 2. Please keep the parentheses there. Negative 4 minus 2 is negative 6. Please keep the parentheses there. That is extremely important when you are plugging this into your calculator. Extremely important. If you are going to be plugging it into your calculator, you must have the parentheses around the negative 2 with the squaring outside of it. The parentheses around the negative 6 with the squaring outside of it. It makes a difference. So negative 2 times negative 2 is 4. Negative 6 times negative 6 is 36. We add those together to get 40. And then we're going to simplify this. So this is that whole exact answer or approximate answer. I'm going to go ahead and move for the exact answer first and get that d is equal to 2 square roots of 10. An approximate answer would be that d is approximately, not equal to approximately, d is approximately 6.32. Second problem, first step, to identify your x's and your y's. So x1, y1 will be my first point, x2, y2 is my second point, and we're just got to be consistent with our subtraction here. So x2 minus x1 and y2 minus y1. Now, if you'll notice here in both of these, when we're doing the subtraction, we are subtracting negatives. Your calculator can handle that if you plug it in correctly. I understand that when you subtract a negative, you're really just adding a positive. So I have changed these subtraction symbols into plus signs. You also have the option of writing it as something like 2 minus negative 9 squared plus 1 minus negative 5 squared. And as long as you do this correctly and you're plugging that in correctly, you'll be able to get the same answer. Your calculator knows how to handle 2 minus negative 9. That would be the first step in your calculator, is just typing in what that equals. So 2 minus negative 9 or 2 plus 9 is 11. 1 plus 5 is 6, or 1 minus negative 5 is 6. And I dropped the parentheses here because both of my answers are positive. So I don't need the parentheses that I stressed so much about in the first problem. Since everything's positive, I didn't have to worry about that. And then you square them and you add them together. So the exact answer would be that d equals the square root of 157. The approximate answer would be 12.53. I want you to go ahead and try these last two on your own. I understand that you can just speed right on through the video and get the answers, but trust me, it's not helping you. Please pause the video. Try these last two problems, use these first two to help you. Please use the formula, and then you can move forward and check your answers. So I hope you did both of these problems well. The exact answer for this one is 3 square roots of 5. The approximate answer is 6.71. The last one, exact answer is 2 square roots of 5. The approximate answer is 4.47. For this word problem example, it says Charlie and Karen have been dating since Valentine's Day. Charlie lives 4 miles north and 2 miles west of town. Karen lives 3 miles east and 2 miles south of town. How far is it between their houses? And we will round to the nearest hundredth. So the point is that we don't really know where town is. Well, we don't know where town is, but they're referencing their distance from town. So we're just going to start at town, and it says that Charlie lives 4 miles north and 2 miles west. So Charlie lives here, and that point, since it's up 4, but it's to the left 2, that's going to be the point -2, 4. And I'm putting it in that order because remember that technically the left-right move would be my X value, the up-down move would be my Y value. So that's how I know it needs to go in that order. Then also from town, it says Karen lives 3 miles east. So that's going to be going in this direction. And then 2 miles south. So Karen lives here and it is 3 miles east, but then the 2 miles south will be negative. And since we are moving by X values first, the point that represents K would be 3, -2. And our goal is to find the distance between Charlie and Karen. And I know obviously my drawing is not going to be matching perfectly with the lines here, so don't take that into consideration. The point is that we are simply trying to find the distance between these two, and so we will use these point values to do that for us. So after applying the distance formula, we get that D equals the square root of 61. So we don't talk about distance in that way as far as a real world problem. We're not going to say that Charlie and Karen live the square root of 61 miles away from each other. We would say that they live approximately 7.81 miles away. And even so, we'd probably just say something like just under 8 miles, but certainly 7.81 is more of an appropriate answer than the square root of 61 in this case. Last example here, it says to use the distance formula to determine whether the triangle ABC with those vertices is scalene, isosceles, or equilateral. And I do have the coordinate grid here because I want you to realize that that is a tool you can use to help you. However, what we're really looking for here is distance. And when we have scalene, it means that we would want all three are different. If we found the distances between the 3 points, then we would want all three of them to be different in order for it to be scalene. And isosceles would mean that 2 are the same distance. And then for equilateral, it would mean that all 3 are the same. And again, when I mean all 3, I mean the distance from A to B, the difference from A to C, and then the distance from B to C. So we want to find out what these distances are, and if they're all different, it's a scalene. If 2 of them are the same, it's isosceles, and if 3 of them are the same, then it is equilateral. So let's set this up here. With AB, the points we would be using would be -4, 3, and 4, 5. So that would be x1, y1, and x2, y2. For BC, it would be the points 4, 5, and 2, -3. Again, x1, y1, and x2, y2. And then AC would be the -4, 3, and the 2, -3. x1, y1, and x2, y2. And I hope you understand without having to draw this, that these are going to be my 3 sides. Like, no matter where I drew it, if I had triangle ABC, I need to test triangle or side AB, how it compares to side BC and how it compares to side AC. So even if you don't use the coordinate plane, this is the triangle that we're talking about here in some way, like at least with these vertices labeled. And so these are the points we're using. So go ahead and try the distance formula 3 times. And remember what I said about getting 3 different answers, 2 of the same answers, or all 3 of the same answers. So this is what I got for my 3 answers. I found that AB and BC were both the square root of 68 for the distances, and AC is the square root of 72. So since 2 are the same, but one of them is different, it is an isosceles triangle. Notice that I did not need to figure out the exact the approximate decimal answers for these square roots in order to identify it as an isosceles triangle. I just needed to know what their exact square root answers were. So 2 of them were the same, 1 of them is different, so it is an isosceles triangle. This concludes the lesson on from chapter 6 on lesson 7, the coordinate plane distance and the distance formula. So that's how we find the distance between any 2 points, is we locate them on the coordinate plane and then we use the distance formula.